I went to the thrift store. It was actually Goodwill down in near Rockledge, Florida. And my roommate, I was like, find a book on astronomy or astrophysics or something. And my roommate found this for me. And, it's a random book, seemingly. But if you read it, if you look at it, an introduction to celestial mechanics, okay? There's a lot in here you can learn, a lot of differences that are apparent to me, and understanding how science has become the way it is today. Now, this book was originally published, see here, in July of 1902. And there's another recent edition made in 1914. And this book right here is the copyright was renewed in 1942, and this copyright by Dover Publications in 1970. So we have 50 years, and then another 46 years from then until now, of people believing that this is the kind of mechanics that we need. Now, I'll go ahead and outline what they believe mechanics to be. It says, preface to second edition here. The necessity for a new edition of this work has given the opportunity of thoroughly revising it. The general plan which has been followed is the same as that of the first edition, because it was found that it satisfies a real need not only in this country for those students it was primarily written, but also in Europe. In spite of all temptations, its elementary character has been preserved, and it has not been greatly enlarged. Very many improvements have been made, partly on the suggestion of numerous astronomers and mathematicians. Keep that in mind, astronomers and mathematicians. And it is hoped that it will be found more worthy of the favor which it has so far been received. The most important single change is in the discussion of the methods of determining orbits. The subject logically follows the problem of two bodies, and it is much more elementary in character than the problem of three bodies and the theory of perturbations. For those reasons, it was placed in Chapter 4. The subject matter has also been very much changed. The methods of Laplace and Gauss, on which all other methods of general applicability are more or less directly based, are both given. That basically sums it up. The Laplacian theory has disks becoming spherical objects, yet nowhere in this entire book is it mentioned how the angular momentum is lost. So Laplacian theory falls flat in his ass. And the reason why is because of the way they interpret celestial mechanics. Truth is, they focus on orbits and orbits alone, and gravitation alone. They only have two tools in their toolbox. If they're going to mention mechanics, and if they're going to be comprehensive, I'm learning that it's not going to be done with math, quantitatively only. You have to have a qualitative understanding of the stars in order to correctly interpret them and their interactions with other stars. To have a gravitational perturbation, you have to understand that the star loses mass as it evolves. It's not something that's static, that is forever in some specific orbit and then you can figure out with math equations. You can't do that. You have to look at the star as a physical construct. Physical meaning, as the star evolves, hydraulic understanding changes, the hydraulics of the star changes, the electromechanical properties of the star changes, its structure changes. The fact that the star goes from hot plasmatic to gaseous to solid and liquid material, that's a huge difference. And that's not mentioned anywhere in this book. As well, electromagnetohydrodynamics, it's a big word, or MHD for short. None of that is mentioned in this book. How a fluid moves under the influence of magnetic and electrical fields, that's not mentioned in this book. This book only looks at the object as a single construct, and then they try to place a center of mass on it, and then boom, everything can be determined from that. That's very, very, very myopic. To think, if these people were to look at the stars and realize that maybe there's a lot more to the picture than what meets the eye, they would have a more comprehensive understanding of them. Instead of just looking at our space as being something mathematical, they should have looked at it as something being physical, because that's what stars are, they're physical constructs. And inside of this theory that I'm working on, and others are working on currently, you have a very big plasmatic object shrinking, cooling and dying, becoming gaseous, and into the interior of the star, it starts forming the planet, meaning there's a whole lot more mechanics than what they will willingly consider. As well, we can also reverse engineer the mechanics of a star when it was in earlier stages of evolution by studying the Earth itself. Mountains, basalt plains, plateaus, the thickness of the crust in specific areas, the differentiation of the star. We can reverse engineer the Earth and figure out what happened when. The fact that we find diamonds, diamonds or rain down in the interior of Neptune-sized and Uranus-type stars. It's stuff like that we have to consider. But the kind of thinking that was going on back then wasn't comprehensive because they had very little information to go off of. If anything, the mathematical idea was rainy day physics, if you will. They didn't have enough information to go off of. They didn't have enough understanding of nature to go off of. So they just made it all mathematical, and then they solidified it as this is astronomy. It's only mathematical, and if anybody says anything about it, they're just idiots. They can't understand the complex mathematical perfect world that we live in. But that's not being a scientist at all. A scientist is somebody who tries to make connections with the world. That's my own personal opinion. If you try to block other people off from your study, then you're not being a scientist. You're being somewhat of a closed-minded idiot. You have to make sure that when you study stuff, that you can look at other fields, that you can make connections between other ideas. You just can't place everything as math only, and then that's that. It's horrible. And the theory I'm developing, as well as others are developing, I want them to realize that this stellar metamorphosis isn't about trying to make things into a little narrow thing. It's about connecting and making bridges between the fields. You have biology over here, you have physics over here, you have chemistry over here, you have geology and astronomy. It's like a pentagon, if you will. And you have to connect all the sciences together, and they all connect through the center as well. It's all one big connected thing that we live in. It's nature. Biology isn't just purely biology. There's chemistry in there. Chemistry isn't purely chemistry only. Nothing to do with rocks and minerals. Of course, rocks and minerals are chemical compounds, and life is also chemical compounds. Astronomy has to do with the stars. In this theory, you have the star cooling and dying, forming chemical compounds from the ionized material. That's chemistry. In chemistry, you have enough chemical reactions going on, that's biology. So literally, biological things are connected to stars in astronomy, as well as geological understanding is connected to astronomy as well. Now, being that we already know that the star cools and dies and solidifies and forms large differentiated rocky bodies like the Earth. So it's all interconnected, yet when you have this kind of idea, I'm going to go ahead and read the back for you. It says, an unrivaled text in the field of celestial mechanics, Moulton's theoretical work on the prediction and interpretation of celestial phenomenon has not been superseded. It has now. Today is February 12th, 2016. Find books like this. Try to read them, try to understand. Look at what they're missing. Look at what's going on. Try to understand the history behind the sciences and where they went in the wrong direction. You'll notice a lot about it.